Welcome to the Unit 7 Properties of Polynomials test review for Algebra 2. So the first one is asking if this graph is even or odd. If the graph is going in two different directions, this is an odd graph. Now, if the graph had both of its arms going in the same direction, that would be considered an even graph. In this case, our arms are going in different directions, so it is odd. Now it says, is there a positive or negative leading coefficient? So we're looking for the sign of the first term if this polynomial was written in standard form. So ideally here we want to pretend that this polynomial has hands or arms, and for the positive or negative leading coefficient, we're going to be focusing on that right hand. What is the right hand doing? It's going up towards positive infinity. So we have a positive leading coefficient. And I'll leave this note here to look at the right hand. For the degree is going to be the largest exponent of the polynomial written in standard form. But when we're looking at a graph and we want to know what the degree is, or the largest exponent, we can look at the turns. We count the turns on the graph and then we add 1. So here we have 1, 2, 3, 4 turns plus 1, so the degree is 5. So again, the degree is the turns plus 1. All right, now our end behavior, the x, as the x values or the x-axis approaches negative infinity, what is our graph doing? Our graph is going down towards negative infinity. Next one says, as x approaches positive infinity, what is our graph doing? Well, our graph is going up towards positive infinity. So make sure you read those because it sometimes will say negative infinity first, and I think some of my students don't read that one, and so they end up switching the positive and negative infinities. All right, number 2, is this even or odd? Well, the graph's going in the same direction, so this is an even function. Same direction. Now, positive or negative leading coefficient, we're going to be looking at that right hand again. And the right hand is going down, so this is a negative leading coefficient. As for the degree, we count the turns and we add 1. So there are 1, 2, 3 turns, add 1, so our degree is 4. The end behavior, as x approaches negative infinity, the x value is approaching negative infinity, our graph is going down towards negative infinity. And as x approaches positive infinity, our graph is going down towards negative infinity. All right, good job here. And we'll move on to number 3. All right. And now we can continue. Moving down, we're going to be rewriting the polynomial in standard form and then answering the questions. So, starting with the number 3, when we rewrite our polynomials in standard form, we mean we want the term with the highest exponent first, and we want to continue that all the way down to the lowest exponent, which usually is just a constant. Spelled that wrong. Constant. All right, so for number 3, which one has the highest exponent? Well, that's going to be negative 5x to the 7. Next largest, we have plus 3x to the 4th. Then we have plus x to the third. Then we go on to minus x, and then lastly, minus 4. Our leading coefficient here, so we're looking for that number in front. It is a negative 5, and our degree is going to be the largest exponent, so 7. All right, so number 4. Standard form, largest to smallest. Negative 3x to the fourth plus 7x cubed minus 5x and plus 2. Our leading coefficient is going to be that negative 3. And our degree, or our largest exponent, is 4. All right, pretty straightforward for these. I'll give you a second to try number 5 on your own. We'll give you about 30 seconds to do that. So go ahead and try number 5 on your own. All right, I'm not sure how much time that was, but we will continue. So our largest exponent is negative x to the 5 plus x to the 4 minus x squared minus 3x plus 1. Now our leading coefficient, it is a negative 1. And then the degree of the polynomial, we got 5. Okay, moving on. 7.2 and 7.3, operations of polynomials. So from this section, we need you to know how to add polynomials, how to subtract polynomials, and how to multiply them. When we add polynomials, we're looking at basically combining our like terms, something that you should be very familiar with in Algebra 2, like terms. When we subtract polynomials, the main idea here is to change the signs, but not all the signs. We're just changing the signs of the second set of parentheses. Second set of parentheses. And then combining our like terms. Okay. Hopefully that's not too jumbled together. It says change signs of the second set of parentheses, then combine like terms. As for multiplying polynomials, we will be multiplying, I'm just going to say multiply coefficients. That's the front numbers. And then you add the exponents. And then you'll combine like terms. All right. So, starting with number 5, the addition, we just go straight into combining like terms. Something we did was we did a vertical alignment where we said, okay, minus 3x to the 4 on top of the other x to the 4. Then we have an x squared, so we'll put that right below the other x squared. 14 squared, and then a minus 8, and we'll put those right below. So I know some people really like the vertical alignment where we did this vertically. So negative 4 and negative 3 is negative 7. 3 minus 14 is going to get us a negative 11. And then 14 minus 8, we are left with a positive 6. If you like the vertical thing, you do it that way, that's great. For me personally, I like to just look at them. I draw these weird lines underneath them to show visually which ones match with each other. So here I have an x squared and an x squared, so 9 plus 2, that is going to be 11. Then we have just a negative 7x. There's no x on the left set of parentheses, so minus 7x. And then lastly, we have negative 8 and 4. So that is going to be negative 4. If you like the vertical thing, you keep doing that, okay? All right, for number 7, this is subtracting. So we're going to change the signs of the second set of parentheses and then combine like terms. So what I do is I'm going to say right below 3x to the 4 plus 14x squared plus 8, and then I just cross that out. I'm not dealing with those negatives anymore. They're all positive now, and we can combine. So we have 3x to the 4 and negative x to the 4. That leaves us with negative x to the 4. Then we have 3x squared and 14x squared. Those put together, we have 17x squared. And lastly, we have 14 plus 8, which gives us 22. There's our answer. All right, for the next one, we distribute that negative, aka change the signs of everything in the second set of parentheses. So if it was negative, now it's positive, and if it's positive, now it's negative. Ooh, I think I made a mistake here. This negative is being distributed to the positive 2, so now it is negative 2x. 7 was negative, now it's positive. 4 was positive, now it's negative. And we combine. I have 9x squared minus 2x squared. That leaves us with 7x squared. I have a 7x that doesn't match with another x in the first set of parentheses, so it just hangs out with us here. Then we have negative 8 minus 4 gives us negative 12. As we move on to number 9 and 10, the multiplication, the note I wrote at the top says multiply coefficients, add exponents, and then combine like terms. So we have negative 4x squared times negative 3x squared. That's going to get us positive 12x to the fourth. And then we have negative 4x squared times negative x. So that is going to get us a positive 4x to the 3. And then negative 4x squared times negative 8, that will give us a positive 32x squared. Now we can start with the second term of the first parentheses. So 4x times negative 3x squared, that's going to get us negative 12x cubed. Negative 12x cubed. Make sure you're aligning the same exponents with the other same exponents, the like terms. So we have 4x times negative x, that's going to get us negative 4x squared. And then we have 4x times negative 8, which is going to get us negative 32x. Now we can go ahead and combine our like terms. This 12x to the 4 will just come straight down. For the next row, we have 4 minus 12, which is going to get us negative 8x cubed. And then 32 minus 4, that's going to be 28x squared. And then this negative 32x just comes down. So our final answer here is 12x to the fourth minus 8x cubed plus 28x squared minus 32x. Woo! All right. Number 10, doing the same thing, starting with our first term and distributing it. So 9x squared times 2x squared is going to be 9 times 2, so 18. X squared and x squared is x to the 4. 9x squared times negative 7x. Well, 9 times negative 7 is going to give us 63. So negative 63 x to the 3. And then 9x squared times 4. Well, 9 times 4 is 36, keeping that x squared. Now we move on to the next term, negative 8. Negative 8 times 2x squared is, negative 8 times 2 is negative 16x squared. and make sure we align the like terms. So the x squared and the other x squared need to go on top of each other. Then we have negative 8 times negative 7. So that's going to be positive 56x. And then negative 8 times 4, which gives us a negative 32. Now we can combine our like terms. These two first terms have nothing to combine with, so they come straight down. Now we have 36 minus 16, which is a positive 20x squared. And same thing with these two. Nothing to combine with, so they just come straight down. Woohoo! All right. Moving along to the long division. For the long division, you can divide polynomials using long division. You can write the quotient in standard form. So this is going to be long division, and in the next section we'll be doing the synthetic division, which I know you all love so much. So the long division steps. Step 1 is going to be to divide. Step 2, we will multiply. Step 3, we will change signs. And our last step, your favorite, bring down the next term. And then we will repeat this again. All right, so first let's go ahead and set up our problem with the 2x plus 3 being on the outside. And on the inside, let's double check, do we need placeholders? Well, we have x to the 2, we have x, and our constant. No placeholder needed. All right, so starting with our first step, divide. We're going to take that first term inside the little box and divide it by the first term on the outside. So we have 2x squared divided by 2x. That leaves us with x. So that x is going to go on top of the other x. Now we're going to go into multiplying. So that x times 2x is going to bring us right back to 2x squared. And then x times 3 is going to be 3x. This is where we change the sign. So we have a negative and a negative now. 2x squared minus 2x squared, that should cancel out. Negative 17x and negative 3x will get us 17, 18, 19, 20. So negative 20x. Bring down that negative 38. All right, and we go right back into dividing. So negative 20x divided by 2x, that's going to leave us with negative 10. 20 divided by 2 is 10. It's negative. X's cancel out. If you want to see it over here, I'll do that really quick. Negative 20x divided by 2x will be negative 10, and the x's cancel out. All right. So now we're going to take that negative 10, go back into multiplying. Negative 10 times 2x, negative 20x. Negative 10 times 3, negative 30. Change the signs. 20 and 20 cancel out. Negative 30 and negative 38 and 30 ends up being negative 8, which is our remainder. So our final answer will be written with what you have at the top. So we have x minus 10, and then our remainder, it's negative, so I'm going to say minus 8 divided by our 2x plus 3. And there's the answer. All right, number 12. Use long division to divide the polynomial. All right, another long division. So we set it up. 5x minus 4. 50x cubed plus 10x squared minus 35x minus 7. We forgot to check if there was a placeholder needed, so real quick we go 3, 2, 1, constant. We are good, no placeholder needed. Just to mention really quick, a placeholder is needed when the x's skip a level almost. They skip an exponent. So if your exponents went like x to the third, and then you had an x, and then you had a constant, we're missing that x to the 2. So you would need a placeholder that said 0x to the 2 right in between that little section there, okay? But if your exponents drop down sequentially in order without skipping any exponents, then you are good to go. Oops, okay. So starting with our first term, 50x cubed divided by 5x. 50 divided by 5 is 10. X cubed minus x is x squared. So we have 10x squared. Next, we go into our multiplication. So we're going to say 10x squared times 5x. That should always bring us right back to that original term we divided from in the beginning. If it doesn't, you're doing something wrong. All right, 10x squared times negative 4 is going to be negative 40x squared. Then we change our sign. So negative, positive, combine. 50 and 50 cancel out. 10 and 40 ends up being 50x squared. Bring down your next term. All right, now we go back into dividing. 50x squared divided by 5. Well, 50 divided by 5 is 10, and x squared minus x is just x. We go back into multiplying. 10x times 5 should bring us right back to 50x squared. And then we have 10x times 4, negative 4, so negative x. Change your signs and combine. 50s cancel out. 40 minus 35 leaves us with 5x. Bring down your next term. We go right back into dividing. 5x divided by 5x. Ooh, we get a nice positive 1. Now, 1 times 5x leaves us with 5x. 1 times negative 4 leaves us with negative 4. Change those signs. These cancel out. Sorry, I'm running out of space, but negative 7 plus 4 leaves us with negative 3 as a remainder. So our final answer is 10x squared plus 10x plus 1, and this is a negative 3 over here, so minus 3 divided by 5x minus 4. Perfect. All right, now that we're back into our synthetic division portion, I'm sure you are all taking a nice sigh of relief. So for the synthetic division, we want you to be able to divide polynomials. Oh, I think it says the same thing, long division, but let's pretend that says synthetic division. And you want to be able to write the quotient in standard form, which you all know how to do. All right, so we check for placeholders. We have 3, 2, 1, constant, we're good. No placeholder needed here. Now, let's go ahead and draw our L. And the number that's going to go right here is going to be whatever you see here, opposite. So here we have negative 3. So the number that we're using here is going to be a positive 3. If you're wondering why, we would say x minus 3 equals 0 as if we're finding the root or the 0, which would give us x equals 3. So using that 3 here, we're going to start by labeling our columns with our x's. So starting here, we have an x to the 3, we have an x squared, we have an x, and a constant. And again, if you for some reason are missing, there's a gap in your sequential order of the exponents, then you need to make sure you use a placeholder. In this case, we are good to go. Next, we will list our coefficients. Here we have 1, 1, negative 5, and 3. 1, -5, and 3. Our first step is to bring this 1 down. Now we have 1 times 3, which gives us a 3. Then we say 1 plus 3, which is 4. And then we multiply by 3 again. 4 times 3 is 12. Negative 5 plus 12 gives us a 7. And we go back into multiplying. 3 times 7 is 21. 3 plus 21 is 24. So now I like to label each of my numbers. So before we start labeling. Our original degree, our highest exponent, is 3. My answer has to be 1 degree less. Maybe make that a note here on your review. Answer needs to be 1 degree less than the original problem. And you might be wondering why. Why is that? Well, we're essentially saying x cubed divided by x. We're looking at those first terms. Well, x cubed divided by x is going to leave us with x squared. So your first term has to be 1 exponent less, 1 degree less. And then we just label them down. So we have x squared, x, our constant. The number hanging out at the end is going to be our remainder. So the way we write our answer, we will say x squared plus x 7 equals, oh, sorry, not equals, ooh, getting ahead of myself, plus 24 divided by x minus 3. That is our final answer there. All right, if you're understanding so far, pat yourself on the back. You're doing a great job. Well, we've officially hit that 30-minute mark of the video, so let's continue. If you'd like to take a break, this might be a good time for a little break. But this problem gets some really high numbers. I had to do it like 3 different times just to make sure I was doing it correctly. So not a fan of the super ridiculously large numbers, but it's all right. We'll be fine. Okay, so first let's check for any placeholders. We have x to the 4, x to the 2, and x and a constant, but we're missing an x to the 3 in here. So we need to make sure to include a 0x to the 3 right in between the x to the 4 and x to the 2. So getting started with our setup, we will do our little L. And let's go ahead and do x to the 4, x to the 3, x to the 2, x, and our constant. Now, for the number that goes on the outside here, again, we just look at the number that we're dividing by and we're changing it. So it's positive 4, so right here we're going to put a negative 4. Now, again, if you're wondering why we do that, we say x plus 4 equals 0, subtract 4, and we get x equals negative 4. So that's the number we use. We look for the root of the divisor. I think that's the divisor. Dividend, divisor, yes. Okay, so starting with our coefficients, for the x to the 4, we have 12. And then for the x to the 3, we don't have one, so we put 0. There's our placeholder. And then we have x to the 2, which is 10, negative 35. All right, so now we got to add that negative 7. Going to bring down that 12 to get us started and start multiplying. 12 times negative 4 is going to get us negative 48. 0 minus 48 is negative 48. Then we multiply again. Negative 48 times negative 4. I already put this into a calculator, so I'll spare you the time, but it is a positive 192. 10 plus 192 gets us 202. We go back into multiplying. 202 times negative 4 is a whopping negative 808. Negative 35 and negative 808 gets us to negative 843. That times 4 gets us 3,372. Positive. So negative 7 plus 3,372 leaves us with a remainder of a positive 3,365. So now we need to label our coefficients here. So our first coefficient, or sorry, our original degree was a degree of 4. So that means we're going to be 1 less. So we'll start with x to the 3 and go down. So our final answer here is 12x cubed minus 48x squared plus 202x minus 843 plus 65 divided by x plus 4. There we go. I'll give you guys a second to get caught up on that. All right, moving on. We have factoring cubic and quartic polynomials. Remember, cubic is like 3 and quartic is like x to the 4. So your learning criteria for this is that you can factor out the GCF, that's the greatest common factor of a polynomial. You can factor by grouping. You can factor by using a difference of squares. That's when we do the t-chart and we look for factors of a times c. And then I can factor using sum or difference of cubes. All right. So number 17, factor by grouping. So someone in one of my classes asked me a great question. They said, how do you know when to factor by grouping or when to use the t-chart? Here's a quick answer. Factor by grouping. You do factor by grouping when you have 4 terms. If you only have 3 terms, like for example in number 18 here, we only have 3 terms. So if we didn't want to factor out the GCF, if we wanted to factor it just all together, we would multiply A and C to start a t-chart, and then we'd have A times C at the top, and we wanted things that would add up to the B value of -9. The reason we do the t-chart is solely to split that middle term into 2 other terms so that we have 4 terms to group. Because in order to group, we need 4 terms, 2 in the front and 2 in the back. So yeah, you group when there's 4 terms, and you use the t-chart when there's only 3, so that we can split it, the middle term, into 4 terms. So we have a nice grouping here, 12x cubed and -9x squared. What can we factor out from both terms in this section? Well, 12 and 9 are both divisible by 3. And for the x's, the highest exponent that we can take out is going to be the smaller of the 2 exponents. So we have 3x squared. And then from 4x minus 3, well, 4 and 3 don't have any factors in common other than 1. So our first set of parentheses is going to be 3x squared plus 1. Our second set will be what we're left with. I like to look at the right side for that. So 4x divided by 1 is 4x. -3 divided by 1 is -3. And that is our answer. 3x squared plus 1 times 4x minus 3. All right, number 18, it says factor out the greatest common factor. So we look at our coefficients, 3, 9, and 6. What are all 3 of these numbers divisible by? The greatest common factor they have. Well, they're all divisible by 3. Okay, so far, we're going to divide all of these by 3. But what about the x's? What is the largest x we can take out, we can divide from each of these terms? Well, we look at the smallest exponent. Here we have x to the 1. That's the smallest x we have, so that's the one we're going to take out. So 3x to the 4 divided by 3x, well, sorry, let me rewind a second. We're taking out 3x as our greatest common factor. So 3x is going to go on the outside of the parentheses, and then we take each of these terms and we divide, and what we're left with goes inside the parentheses. So 3x to the 4 divided by 3x. 3x and 3x cancel out, and we're left with 1x. 9x squared divided by 3x. Well, 9 divided by 3 is 3. X squared minus x1 is just x. Next, we have 6x divided by 3x. Well, 6 divided by 3 is 2. X divided by x is 1. So Our final answer is 3x times x plus 3x plus 2. Something I didn't mention during the division that you might need, I listed all the tricks and the tips for subtracting, adding, and multiplying polynomials, but I never said dividing. So when you divide, it's the exact opposite of multiplication. You divide the coefficients and you subtract the exponents. So in multiplying, we multiply coefficients and add the exponents. Dividing is exact opposite. Divide the coefficients and subtract the exponents. Taking that knowledge and moving on to number 19, it says factor using the sum or difference of cubes. So when we have the difference of cubes, I'm going to zoom in here. What I like to do is set up, this is going to be our a cubed, and this would be our b cubed using the formula. So if we have a cubed equals 8x cubed and b cubed equals 27, we need to solve for a. So to solve for a, we would take the cubed root of all the terms here. Cubed root of a cubed is just a. The cubed root of 8, well, 2 times 2 times 2 is 8. And the cubed root of x cubed is just x. Now we also need to find our a squared. So we would say 2 squared times x squared, which gives us 4x squared. Now let's look at our b. We take the cubed root of both terms. It's kind of ugly, but you know what I'm doing. We end up getting b equals, what's the cubed root of 27? It is 3. Because 3 times 3 times 3 is 27. Now we need our b squared because the formula calls for an a squared and a b squared. So b squared is going to be 3 squared, which is 9. And to write our answer, this is the sum of cubes. So make sure you're looking at the right formula as you're completing this review. Our final answer will be a plus b, so 2x plus 3. Here's a and b. Our next set of parentheses will be a squared, so 4x squared, minus a times b, so 2x times 3. 2x times 3 plus 6x, so minus 6x plus our b squared, which is 9. So all we did was do a little magic with a squared, and b squared, and then we plug those numbers into the formula. So I love sum difference of cubes, very simple. Now on the test, the sum difference of cubes problems, there will be one sum, one difference, and it will give you the exact formula to use. So you won't be guessing which one is which or did you use the right one. The formula will be right there with the same problem. All right, number 20. Factor using the sum or difference of cubes. Well, here we have a minus sign, so we're going to be using the difference of cubes. Again, the problems on the test will give you the exact formula you need, so don't worry about, you know, accidentally using the wrong one. Won't happen. Okay, so again, we want to start with our a cubed is going to be our x cubed, our first term, and our b cubed will be our second term. So we cube root both sides. That gives us a equals x. So a squared will give us x squared. Easy enough. Now we have a cubed root of b cubed and cubed root of 125. So that ends up getting the cubed root of 125 is 5 because 5 times 5 is 25 times 5 is 125. 5. Okay, so 5 times 5 times 5, 5 cubed is 125. So now our b squared is going to be 5 squared, which is 25. We're going to be using these terms for the formula. So the formula goes like this. We have a minus b. A is x and b is 5. So x minus 5. Our next set of parentheses will be a squared, which is x squared, plus a times b. So here we have x times 5, which gives us 5x. And the final term is plus b squared, which we said was 25. And there's our difference of cubes. For number 21, we are factoring, and this goes back to what I said earlier about, are we grouping or are we using the t-chart? Well, we have 4 terms here, so we can go right into grouping. No t-chart needed. So from the first section, x cubed and negative 4x squared, we can't take out a 4, so we're just going to take out a 1, which you can, or you can write, or you can omit writing the 1. So x cubed minus x squared leaves us with x. So we're taking out a 1x. From the second section, we have a negative here, so we need to take out that negative. Now x and 4 have nothing in common, so we take out a 1. So our first set of parentheses will be x minus 1, and our second set will be what we're left with when we factor whatever we decided to factor out. So here we have, oh, I'm actually noticing that I made a little mistake. From the first section, we take out the lower of the two exponents. So we would take out an x squared. So little quick fix there. All right, back to the what we're left with. Negative x divided by negative 1 is positive x. 4 divided by negative 1 is negative 4. Now, are we done here? No, we are not. So here we have x squared and 1, which is a perfect square because the square root of 1 is 1. So this can be difference of squares, which ends up being x plus 1 times x minus 1. Just bring down that x minus 4. And now we have fully factored, just like it said, factor completely. All right, number 22, we are almost done, guys. Number 22, factor by grouping. All right, it tells us, so we go right into the grouping. From the first section, 5 and negative 10, we can take out a 5. From x cubed and x to the squared, we take out the smaller exponent. From the second section, we have 3x and negative 6. They're both divisible by 3. So our first set of parentheses will be 5x squared plus 3. And then our second set will be what we're left with when we divide or factor out that term. So 3x divided by 3 is x, and negative 6 divided by 3 is negative 2. Are we done here? Yes, we're done here. All right, we can go ahead and move on to number 22, or sorry, 23. Factor completely. We have 4 terms, so we go right into grouping. X cubed minus 5x squared. Well, 1 and 5 had nothing in common, so we'll take out a 1. Our lower exponent is 2, so we'll take out that x to the 2. Now for the second set, it's negative, so we need to factor out a negative. So again, we only factor out a negative if our first term in the second set is negative. In this case, we have a negative x, so we take out that negative sign. From x and 5, we don't have anything in common, so we take out a 1. So our first set of parentheses will be x squared minus 1. Are you noticing what we did? Are you noticing that this problem is starting to be kind of similar to what we have here, x squared minus 1? If you are, good. Our next set of parentheses will be what we're left with. Negative x divided by negative 1. That's going to leave a positive x. Now 5 divided by negative 1. That's going to leave us with negative 5. We are not done here, guys. We are almost done. So here we need to factor this out more. So we have x minus 1, x plus 1, and then bring down that x minus 5. Some of you might be wondering, does it matter if the minus or plus is first? No, it doesn't, because when you FOIL it out, it's going to go right back to the original x squared minus 1. So no, whether it's plus or minus first or second in the difference or sum of squares, no, it does not matter. Where when you're dealing with the sum or difference of cubes, you follow that formula to a T. If you mix up the negative, like here, if you mix up this negative and positive, it's not the same. This is different, okay? So here, difference of cubes, we have positive and positive. So if you're using the cubes, follow the formula to a T. If you're using the squares, square both terms, and then you've got 1 plus and 1 minus, okay? Okay. Now our final one, woo, 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 woo. So for the final one, it tells us to use difference of squares. So what I'm going to do is I'm going to rewrite this with a little bit of space so I can make all of my little markings. Difference of squares. So we need to be using the square root. We're going to square root every term. Square root of 4 is 2. Square root of x squared is x squared. And square root of 1 is 1. So we're going to use those terms. We'll have 2x squared minus 1 and 2x squared plus 1. Are we done here? I think so. Yeah, because we can't take, if we wanted to go further, we could try to take the square root of these, but 2 is not a perfect square, so that's why we stop right there. Okay, that is our final answer. All right, so thank you for listening to my video. For good test taking strategies, or at least study strategies, I would highly suggest you complete as much as you can of this, and then go back to each of what is this? Success criteria or learning targets, and check off what you're comfortable with. Can you factor by grouping? Yeah. Can you factor out the GCF? Maybe you're a little weirded out by that. Okay. Check off what you know and what you feel confident doing on your own without help or even without this video. And then go back and work through some problems of the things that you don't feel confident on. Like maybe multiplying polynomials is not your strong suit. So go back and study that. These success criteria being here will be a nice guide as to what you need to study and what you need to focus on more during the next couple of days of studying. All right, thanks for watching and good luck on your test.